Hi Mr. Imran. This is a presentation on dehydrohalogenation done by both Ishans, Jody, and Daniel.
Dehydrohalogenation is an organic reaction where alkyl halide, when boiled with alcoholic alkali, gives a corresponding alkene. It is defined as an elimination reaction that results in the removal of a molecule of hydrogen halide, and in which a hydrogen atom and a halogen atom are removed from adjacent atoms in a molecule that forms an alkene or an alkyne. So there are a few reactions that can take place under dehydrohalogenation, and one of them is ethyl chloride reacting with potassium hydroxide dissolved in ethanol to give ethane. And the other one is 1-chloropropane that reacts with potassium hydroxide. And the last one is 2-chloropropane that reacts with potassium hydroxide dissolved in ethanol.
Elimination reaction in which a base removes the elements of an acid from the organic starting material. For example, 2-bromo-2-methyl-propane. The base removes a proton from the beta carbon, and the electron pair in the CH bond forms the new pi bond between the alpha and beta carbons. The electron pair in the CX bond ends up on halogen, forming the leaving group X minus, which is in this case bromine. So the removal of the elements of HX is called dehydrohalogenation because a hydrogen is removed and a halogen is removed as well, and is one of the most common methods to introduce a pi bond and to introduce an alkene.
Dehydrohalogenation is an example of beta elimination, which is a chemical reaction in which atoms or groups are lost from adjacent atoms. Because it involves the loss of elements from two adjacent atoms, the alpha carbon bonded to the leaving group X and the beta carbon adjacent to it. Beta elimination of an alkyl halide with a strong base forms an alkene via the E2 mechanism, which is a base abstracts a proton neighboring the leaving group, forcing the electrons down to make a double bond and in so doing forcing off the leaving group. The reaction follows the Zaitsev rule, giving the more highly substituted alkene as the major product.
The figure below shows the dehydrohalogenation of alkyl halides resulting in the formation of alkenes. Dehydrohalogenation of alkyl halides is a reduction reaction where a halogen and hydrogen atom is removed from the alkyl halide in the presence of a base such as sodium hydroxide and potassium hydroxide. The electrons that were once bonded to the halogen and hydrogen are now free to form a CC double bond, forming an alkene with a hydrogen halide as a byproduct.